So you don't actually ever have to leave your terminal. You can just sit there and watch it scroll by as it does things, and it's really cool. And it also uses different colors and stuff. It's really pretty as well. So back when we first did this, we had like one special server, which had a bunch of like magic cron jobs on it. So you don't really want those cron jobs running on multiple servers, because then it's like sending things out twice and doing scheduled tasks multiple times, and it's just horrendous. So you need to have like one special server that has your cron jobs on it, and it's kind of like a pet where you don't want that server to crash, and you only have one of them. But then you can have your other servers that you can just create 10 of them or 15 of them if you get lots of scale, lots of users coming on. You can just create more ones and scale it up. So that's kind of like the first step you go to. Like you're trying to treat your servers as cattle and not pets. You might need to have one pet just because you have cron jobs, which I would not recommend, but they're kind of the easiest way to get scheduled tasks happening. But also the beauty of having these bash scripts is then you can use those same scripts to build a dev box. So then when you bring on a new developer, you can just run your script against a vagrant box or a virtual box, and you give them the brand new box, and it's exactly the same as everybody else's. And this solves a hell of a lot of problems where everyone's got the same version of GoScript all of a sudden. So then things are reproducible in dev if they happen in production, which is kind of the end goal, really. This is the main reason why I think you should do this first, is that you get that kind of, what's the word, where production and dev parity. Production and dev parity, so that everyone's running the same things, essentially. So from there, once you have those bash scripts, you can now create CI build servers pretty easily, because you know exactly what's needed to run your code. So you can use CI, you can build CI Docker containers that you can run in GitHub Actions or in Circle CI or wherever you need to. You can also build like whole servers that you can plug into things like TeamCity or something. You just build a whole server and you point TeamCity at it and say, hey, build my code on this. And then once you have your CI things, you can start adding in like automated tests and static analysis and that sort of stuff, which has a pretty like high barrier to entry. You have to have a lot of framework and groundwork around that to make that actually work. And it's something that no one's ever going to do if you're fixing a bug in production. If there's something, it's a bug in production, I can fix it now. It's going to take me 10 minutes, then I can deploy. No one's going to spend an extra 2 hours like installing PHP unit and Mockery and setting up your foundations for your testing. But if you already have that in place and it's only going to take you 10 minutes longer to write a test case to prove this bug's never going to happen in production again, it's much easier to convince your team that they need to write tests. And then you can move on from that into deployment phase. I've never personally got to continuous deployment, which is where as soon as a pull request is merged, it goes straight to production. That's mostly because I want to kind of manually QA things before they go out. The way around that is to write things like Selenium or Cypress tests, which are just slow and flaky. So I just haven't really got around to doing that. I would love to be in continuous deployment mode where something's merged, it just goes straight to production and you know that it works fine. But I just need to have like a little bit more confidence in things before it goes out into production. And then at this point as well, if you can bring in migrations as well, I think you get bonus points there, like database migrations. So you don't have to, if you change database schema, you don't have to like manually run like update table commands on your production database. If you have them in migrations, then you get things like code review. You can run automatic scripts and tests to make sure that your up and your down and your migrations work, so that you can like roll it back if you need to and things like that.
And your dev boxes get migrations as well.
And your dev boxes, so you don't, back before I had migrations, you'd have to like I'd send a big like SQL command around to everyone. This is like 5 update table commands, and everyone run this on your box real quick, otherwise next time you merge it's going to be broken.
Also the share drive just had like a database dump production where we just cleared out an email column the previous job.
Yeah, like we dump the production database and you just like reset everyone's all the usernames and passwords to get like some sort of privacy for our users, and then you just hand that around to the devs, and then at a certain point that database gets so big that it takes people like 2 hours to import it. So then you have to do like some magic SQL hackery to go in there and like delete a bunch of tables that you don't really need, but you kind of need, or like delete data out of tables, and but you want to keep some data there, and it's not fun. Just use migrations. So now once we get to that, now we can start to Terraform some stuff. So Does anyone not, has everyone heard of Terraform? I don't know how much kind of background I need to give. Has everyone heard of infrastructure as code, that sort of thing before? So Terraform is kind of a competitor to something like CloudFormation if you're in AWS land. It's kind of a way of just storing your infrastructure as code. You can get code reviews on it, you can store it in GitHub, things like that. So you write down like, oh, I want a server and I want it to have an IP address and I want it to be built from this AMI and I want it to be in this region, like in Sydney or whatever. And Terraform just kind of creates that. It uses like the AWS API to create that. The beauty about Terraform is it's cross-platform. So you can manage AWS infrastructure, you can manage DigitalOcean, you can manage Azure, whatever you want. You can even manage a Google Calendar if you want to. Someone has legit written a plugin for Terraform. You can create events in your calendar with Terraform. It's amazing. But we use it for stuff outside of infrastructure as well. We manage our GitHub account with Terraform. So any new repositories we need, create them in Terraform. Any new developers that we onboard, we give them permission to our GitHub through Terraform as well. So it's all committed to version control. So you don't forget to like remove someone from GitHub or you don't accidentally change some settings on your GitHub repository. So all of our like CI infrastructure and stuff is all in Terraform as well.
Probably worth mentioning the whole like it's a state. Like you don't write like a script to go and create things, but it's like you write what it should be and then Terraform gets you to that state. Does that make sense?
Something, yeah, it's one of the things that's really interesting about Terraform is if you think about normal code like PHP, it's what they call imperative, I think, where it's just like if you think of it executing, you can read each line of PHP and you can pretend that you're the computer and you're executing it. Terraform is not like that. Terraform is, I have a block and it's like a server with an IP address and an AMI and in this region. And then Terraform will go out into your AWS account and it will know if it already knows about that server. And it will be like, oh, that server exists, but it's like got the wrong IP address. I'm just going to change its IP address. Or if the server doesn't exist, it will create it. Or if it's in the wrong region, it'll destroy it and create it again over here. So you just kind of tell Terraform, this is the state that I want. Go and figure it out for me. It's kind of similar to like functional programming. Like if you've used Haskell or some hardcore functional programming like that, they do a similar thing where you might specify, like even like array map in PHP is similar. You give it an array and you give it, I want you to do this thing on the array for me. And it'll, in the background behind the scenes, run your callback across every element in the array. But you don't have to write that for loop. That for loop is done for you by the PHP engine. Similar thing with Terraform. It kind of just figures out how to get to the end state for you. So kind of where I started with Terraform was then you find the hard parts of your infrastructure, the hard things to manage, the things that are like kind of, it's a lot of different options. And in AWS, it's easily like your VPC, which has just got all these different things here you need to set up to have a VPC that kind of works. I know in Azure, they don't have VPCs. So the one time I used Azure, that just threw me because I didn't understand how things were grouped. But in AWS, you have like a VPC, which is your private cloud, which is kind of, you create a VPC for your application and you create subnets so you can separate all your servers. So you have your web servers in a public subnet that having access to the internet, you have your databases in a private subnet so people can't access it and hack into your databases and things like that. But in order to do your VPC, you have subnets and DHCP and internet gateways and NAT instances so that your private instances can also access the internet if they want to, but things can't come through the other way. And all of these things to create. And if you're going through AWS console to create them, you've got to go through like 5 different AWS services and create them all and link them all and put in the right options. And it's error prone and it's horrible. I think I've got, here we go. That might be a little bit small for everyone. This is kind of the most simple example of a VPC that I can come up with for Terraform. So you create your VPC up here, you tell it, this is like kind of the IP address range that I want it to use. You have to create internet gateway, which is kind of like your, I guess your modem for the internet. It's like how your servers, if your server wants to talk to the internet, it has to go through internet gateway. And then you have a public subnet here, which is where you put all your servers that you want to be able to reach from the outside world. So your web servers, for instance. And they need to know about, they have to have a route to tell them how to go through to the internet gateway so that they know how to get there. This is all like kind of low level networking stuff. Like if you've ever set up like your own networking switches or anything like that, you've probably seen most of this before. But then you have a private subnet. A private subnet is the same as a public subnet, except instead of connecting to an internet gateway, it connects to a NAT gateway. And that's just kind of like, if you think about your modem at home, your computers connect to your modem and you can go to the outside world, but people on the outside world can't come and connect directly to your computer. They get stuck at your router, essentially. That's where you have to set up like port forwarding and stuff like that to do games and all that sort of shit. So that's kind of what your NAT gateway does. It stops people on the outside world coming through and connecting directly to your servers. But this is a good example of Terraform. See, it's if we look at like a subnet, it's got like you say, I want a resource. It's going to be this AWS subnet, which is your magic keyword, so Terraform knows what it's creating. And then you give it a name. And then these are all the different options that get passed into here. And then behind the scenes, Terraform queries the AWS API and then figures out what it needs to do and what it needs to change, and then it will just kind of do them. And the other thing it does is it keeps track of state. So once you've created this subnet, it knows, oh, I've created that subnet before, and it stores that in a state file. The most simple case, it'll just store that in a file on your local file system, and you can actually like open that file up and have a look through, and it's just like a massive JSON blob of essentially the response from the AWS API. And then if you came through here and you changed this like IP address range for your subnet, the Terraform can then use the AWS API to then just update your subnet instead of deleting it and creating a new one. Or if you wanted to delete this, you could just delete this whole resource, and Terraform looks at the state and says, oh, hey, I used to know about this subnet, but it's not in the code anymore. I'm just going to delete the subnet. So the thing is, then once you've got this, you can run Terraform apply, and then it just looks at all these resources, figures out what it needs to do, and it does them. And then you can just keep running Terraform apply, and if you haven't made any changes, it's fine. If you have made changes, it'll update them for you. Then you've got the scary one, which is Terraform destroy, which will then just like literally delete everything. So there's ways around that. You can put in like little blocks on your production servers and things so they don't actually get destroyed, but just don't run Terraform destroy unless you want to. So I've only ever run it on like staging environments, for instance, and it's always terrifying. You're on Terraform destroy and you're looking at it and it's deleting things and you're like, shit, am I in the right directory? Immediately in production. And you're like quickly checking that the servers are still up. So yeah, that's fun.
It's probably worth pointing out the like dependencies sort of thing that goes on, like how you can inject essentially a resource into another one.
Yeah, so like the VPC up here, for instance, you create this and all it needs to know is what IP address range it needs. But then when you create your internet gateway, it needs to know what VPC to create internet gateway in. So then the way that you use references is you say, hey, find me an AWS VPC, which is got a name of this, so you can see it's got the name up here. And then you've got a bunch of attributes that are then exposed on that resource. So you can access its ID, or you can access its CIDR block if you want to as well, or IP address range, and things like that. So you can see that a lot of them reference like other resources here, like subnets and VPCs, NAT gateways, things like that. So this is a very simple Terraform script. It can get a lot more complicated than this. And then I think, yeah, so the thing now is if you write this and then you run Terraform apply, it's going to go and create it all, but you very likely already have all this that you've created manually in AWS console or in DigitalOcean or wherever you manage infrastructure. So you don't want to have to like delete production and then create it again. So this is kind of one of the really big benefits of Terraform over something like CloudFormation, which is the AWS specific infrastructure as code that they provide, is that you can like import existing resources into Terraform. So you create your Terraform directory, main.tf is just the file, it's just like index.php largely. And then you can say, hey, I want to import a VPC. I want to store it in the VPC that's got the name of this, and it's got this ID. So then Terraform goes to AWS and it says, hey, give me that VPC with that ID. And then it just stores that in the state file. And then Terraform essentially just thinks that it created it, it manages it entirely. And then you can all of a sudden manage that VPC within Terraform, and you don't have to create it or destroy it first. It's just there. So this is kind of like very basic state manipulation in Terraform, and it sounds really scary. And I was absolutely fucking terrified of it when I first heard it. Like manipulate my state in Terraform. I was like, oh, this feels like I'm behind the scene and it's terrifying. But really, you're just editing this like a random file. It's not actually modifying anything in production because it's just what Terraform thinks production looks like, or staging or whatever. So you can just kind of like keep messing with your state until it does what you want it to do. And the other good thing about Terraform is when you run Terraform apply, it will tell you what it's going to do before it does it. Whereas something like CloudFormation, which always scares me because you kind of like, you make your CloudFormation script, you upload it to AWS, and then you say execute. And then it gives you a little spinning wheel that says in progress, and that's all you get. And then at some point it says success, or it says, oh, failed, oh, roll back. And then it tries to roll back. I don't even know what it rollbacks. I didn't include that in my script. I don't know how it does that. And then sometimes it gets stuck in that rollback state for like hours until some arbitrary timeout thing in AWS decides that it's okay and it's allowed to cancel, and then it's not fun. But Terraform gives you this nice plan. It says, hey, I've noticed that you've changed your IP address for this server. I'm going to update that. And it tells you it's going to do that. So then you can say yes or no, essentially. So once you've imported all these things, you can then run Terraform apply, Terraform plan, and it will tell you if you've imported it correctly, essentially. Yeah, so kind of where we're at now is we've kind of created our VPC, but if you've noticed back here before, this is kind of a lot of code. This is a very simple VPC. It gets a lot bigger than this, but if you say you import your staging VPC and now you want to do production as well, you don't want to have to copy paste all of this. So that's where you can start to use modules. So initially I copy pasted everything because I was scared of modules again, because it's just something new and terrifying. And for some reason, it's like whenever you're dealing with like your production servers, anything new just kind of scared me. I don't want to change it because it's kind of working and I don't want to touch it. But again, with Terraform, you've got like that state file manipulation, so you can just keep on changing things until it's right, until it tells you that it's not going to destroy your servers, and then you're probably fine. So you can create, so here I've created a module, a custom module that's got my infrastructure changes, my VPC and stuff in here. And I pass in a bunch of parameters into it. So this is similar to just defining your own PHP function. You can see here's my like IP address ranges from before, but I've also updated my module to also create a database and Redis instance and things like that as well. So now this is all I need in my main.tf file, and it will create my VPC, and it also creates databases and Redis instances and all sorts of stuff. So then I can just copy paste this like 10 lines of code, and then I can create multiple environments that are all up and running, and they're all the exact same except for these exact parameters. Like you just want your database password different, but everything else needs to be the same. And that's kind of how you get, before we were getting the parity between your servers and your development environment, but now we can have parity between like staging and production as well, in terms of like your infrastructure and how it all hangs together. So you can see our directory structure now looks like this. You have a modules directory with your main in there, and then you've got both staging and production. So then all these ones do is use the module in here and pass in different variables and things that are different between environments. But now we have a new problem of, before we had our main file in the root of here. So like all of our Terraform state was in this root directory, and we want to move it into these folders and into these modules. So just with more state manipulation, you can say, hey, Terraform, this VPC that used to exist here, and so we had a VPC that was called this. Now that VPC is actually called module.infra.awsvpc.this. And then Terraform just updates some paths in its magic JSON script, JSON state file. And then it will kind of keep track of where things have moved to, as opposed to if you just kind of moved all your code around and then ran Terraform apply, it'd be like, oh, hey, your AWS VPC called this doesn't exist anymore. I'm going to delete it. You've also got this new VPC called module.infra.awsvpc.this. I'm going to create that one for you. It's not what you want, because then you've destroyed your production VPC. So you can move it around. And that's quite fun to do as well. It's less fun when you have hundreds of things to move. But live and learn. So then the next step after that, so you can probably get, I stayed on this step for quite a while. And then at some point I stumbled across the Terraform registry, which is kind of like packages. So people can like create their own Terraform modules and give them to you, and then you can use them. And you get the same issues that you have on packages. If you want to install a composer dependency, it might not be well maintained, it might have bugs, it might not work for your exact use case, then you have to like modify it in some way. But generally you can find some really good ones, especially these ones in the Terraform AWS modules group. They are really well maintained. They're kind of like the official ones. And then there's a bunch of kind of nasty ones as well, which I usually just use to like look at them to be like, oh, how does this work? And I'll do it myself because I don't want to use something that someone hasn't maintained for a year. But the good thing about modules is you can kind of find new ways of doing things. You might find more kind of idiomatic ways of writing your Terraform code. And you can also unlock extra features. Like this here is a VPC module, very similar to my VPC module, but it allows you to have a NAT gateway and only a single NAT gateway. Instead of having to have 5 of them around for all the different subnets, you just have one. Whereas my module didn't have that. So if I use this module, then I would just get that new feature out of the box, and all I have to do is this one line of code. So I think, oh, there we go. I was meant to delete that slide, don't worry about that. Anyway, so now we've been through a whole process now, and kind of where we're at is we can easily create new environments. So the kind of best example I have of this is just over a year ago now, we had one of our customers wanted a penetration test. So we found a pen tester and they're like, oh, we're going to run some tests against your servers. We didn't really want them doing against production because like if they happen to break something, then it's going to affect our users. Then you also don't want them going against staging because we often break staging because that's what it's for. So copy paste a couple of Terraform files and we can create a whole new environment and just say, hey, pen testing guys, go nuts. Doesn't really matter if you break this. It's completely separate from everything, but it's also the exact same as everything else. So anything you find is going to be reproducible in production. We've also been able to just largely ignore infrastructure and just the servers run, they heal themselves if they break. We get notifications sometimes if they break, sometimes you don't. That's something we're working on. But just being able to like not worry about the infrastructure. We're a small team. We've got 4 devs now. That's exciting. We just hired our 4th dev a couple of weeks ago. But we don't have time for me to be spending all my time clicking on buttons in the AWS console to try and figure out why the servers are broken. So it's nice to kind of like write it once and then forget about it. But a consequence of that is once I write it once and then I forget about it because I haven't done it for 6 months, I come back in and I see all this Terraform code. And I'm like, I have no idea how all this hangs together. But the beauty of it is you've got Terraform code that you can read. It's not a Confluence document that's out of date. Like it actually reflects what is in production right now. So you can read it and learn it. And I've often, like if I go on holidays and Tom wants to do something, he can go in and he can mess around in Terraform and break things, but can always fix them because it's a Git history and things like that. So I always know what Tom has done in Terraform and if he hasn't committed it because the Terraform state is out of sync with the code. But then that also makes it easy to teach people. So yeah, you can just give people Terraform code. You can kind of walk them through it a lot easier than you can like, if anyone's done much with AWS console or tried to teach people how to use AWS console, it's just, there's like 1,000 different things you can do. And it's just like, where do you go? What do you click on? What should you not click on? Because there's big delete buttons all over that place.
No, don't do that.
Seriously,
No, don't do that.
The Terraform docs for specific AWS resources are more complete than the AWS docs themselves. Because you've got like docs saying that like to create this resource, here are the 10 things you need to fill out. It's like, oh, all right, to create like this thing, I also need to create this thing. So click on the docs for that. Like you need to set up with these things. Oh, okay, you follow that. Yeah,
the Terraform docs are really, really good. I often like if I'm wanting to create like a new resource that I haven't done before, I might even like reading both the Terraform docs and the AWS docs. Sometimes I'll even go into the AWS console because sometimes they have nice wizards to create things which automatically creates like 30 things behind the scenes. In Terraform, you have to create those 30 things manually. But if you go into AWS wizard, you can like create it with the wizard and have it how you want it and then import it into Terraform and get it that way as well. There's a lot of different ways to kind of get around that. But kind of, I guess the prompt for this talk was over Christmas, we decided to rebrand our entire app. Not only rebrand it, actually split it into 2 apps. So we had one app, which we wrote a couple of years ago, which was for managing lease negotiations for shopping centres. And then COVID hit and shopping centres didn't want to buy lease negotiation software, but we still had clients. So then we started building another app, which we kind of thought was similar at the time. In retrospect, it is not similar. But now we build construction project procurement management. All right. And then, so we had 2 apps in the one system. So then every time we're releasing new features, we have to check that we haven't broken this code that we haven't touched in a year. It was really annoying. So we wanted to kind of split that up. So we duplicated the code bases, cloned the code bases, and now we need production infrastructure. So all I did was copy paste a bunch of Terraform and then Terraform apply. And in a couple of days, I'd created a whole new separate environment and it was all up and running, and it all just kind of worked with different databases and separate domain names and all the separate HTTPS certificates and all that magic stuff that you need. And it just kind of worked. And there was like 80 or more resources per environment. So for staging and production, you have to create like 80 or more things. Plus our CI pipeline, I had to duplicate that as well. And that's another 70 odd things. So in a couple of days, Terraform created like over 300 different individual things in AWS for me. And if I had to click around and create all those manually, you can guarantee I would have fucked something up because that would have been so bad. But yeah, so that's kind of, once I did that, I kind of realized like, hey, this is actually pretty good. And then you talk to people about it and they want to hear. So hence this talk. So as Tom mentioned before, we are hiring. So again, if you want to kind of work on Terraform, you can kind of hit me up. Does anybody have any questions about Terraform or DevOps in general?
Is it open source?
Terraform, yeah. It's made by HashiCorp.
Okay, cool. So is your Terraform config like compatible with, like, can you just move it between providers, or is it like really specifically AWS because it's like dealing with VPCs and all that sort of stuff? Like, could you move them between providers or?
No, not really. It's not like, Terraform's not like doctrine.
It's not like an abstraction over like
No.
Okay.
So yeah, you can, like, it's very specific. Like all like this is an AWS resource.
So that's not like not like a string that you've come up with to name it. That's like an actual magic thing that it knows.
That's a specific thing. And so Terraform works by having what they call providers plugged into it. So there's an AWS provider. An AWS provider gives you all these like magic strings that refer to AWS resources.
Just swap the docs. Like,
can I have the keyboard?
oh yeah. There's no keyboard. Just pounding on it like that.
Bing. Is there something particular you wanted to see?
Just terraform.io. Just like.
In fact, oh my god.
It's not Dvorak.
It's not Dvorak. I have no idea how to type on this.
Like docs, it is. And then go to like the provider documentation. So like these, like keep going.
Where's the list of providers?
Terraform registry is where it is now. Middle link right in the middle of the page. There you go.
I changed all this recently.
So these are all the different like things, like platforms you can create resources on. So like AWS, Azure, like those are things that are obvious, but then there's like less obvious things. Like we use Statuscake to do uptime checks, and we configure those uptime checks in Terraform so that like we know sort of what state they're supposed to be in, all like the timeouts, what endpoints they hit, and all that sort of stuff. And all these are just like Go modules that you can create yourself to like create your own provider as well. So that like, that's an easy thing. I don't think it's that easy at all. But then if you click into AWS, this is where like when we started doing this, I had very, very limited experience in AWS. Like I knew how to like basically to nuke a EC2 instance and reboot, that's about it. But just like Go documentation. And then on the sidebar, this is like, AWS is notorious for just having like seriously thousands of different services and then two, like just different resources inside all those services as well. So once you finally find EC2, you've still got like all the different EC2 things inside that. So an instance has like all the shit that's associated with an instance even existing in the first place that you need to create, like the volumes, e.g. like how do you attach storage to the EC2 instance. But it's kind of hard to see with this screen, but at the top of this is a filter bar there. If you just search like AWS, yeah.
For anyone who hasn't used AWS before, EC2 is just a fancy word for a server.
VPS.
AWS instance, there we go. So yeah, when you create a instance, you need to have an AMI. This is a fancy, like, this is, so you notice down here, we've got a resource. So this is how Terraform knows we want to create something. So I want to create an AWS instance. I'm going to call it web. I'm going to use this AMI, which I'll talk about in a second. And I just want it to be t3.micro, which is just like
Really small.
2 CPUs and no, 1 CPU and like half a gigabyte of RAM or something like that. I don't know. Just really small server. So then,
so I was going to say, if you scroll down, you see like the full list of like all the attributes. So
yeah,
it's like, there's the minimum requirements of like how big is your server and what is the like image that's running on it. But then there's like a million configuration options, which in the AWS console is right click properties and then just like the biggest wizard you've ever seen to configure everything.
you got like instance profile, which is how you give it permissions to talk to other AWS services.
But notoriously, this is so much easier to use than the EC2 like console, let alone the AWS docs. So it's like easier to do infrastructure in this.
Like your SSH keys, whether you want to give it a private IP address, your hard drives that you want to attach to it, security groups is how people access it. So you can say that SSH is allowed in, but web servers are not, sort of thing. There's tons of things you can do.
Can it do DNS for you as well?
You can do DNS for you. And you can make it automatically create HTTPS certificates for you as well.
So you could, and because it's got multiple different providers, you could kind of roll your own thing where it does some stuff in Cloudflare, some stuff in DigitalOcean, and does it all across services. It doesn't have to be in one provider.
So yeah, you can install your multiple different providers and then get them to do different things at the same time.
You can you have cross-provider like dependencies? So like that resource, like AWS instance 2, once it's created, exposes like an ARN, like scroll.
Get all the way to the bottom.
So once the thing's created, there's like
attributes. So once it's created, you can access all these properties. So it's ARN is the Amazon resource name. It's like a unique identifier for that thing. You can figure out its DNS. You can figure out its public IP. So like, if you wanted like a Azure service to point towards this, you could pull out its public IP and put that into your Azure Terraform things. Then it can point whatever you want at the IP address. You obviously wouldn't be able to use the ARN, which is what most AWS resources will take because it's like the unique identifier.
But the example of like an IP address or something from like DNS pointing to like a AWS resource, you have that cross-platform resource linking. So it's just all in like Terraform plan that just kind of does it all for you.
Yeah. And like the Terraform AWS like managing of your DNS, they call it Route 53. You can just you can create your DNS in AWS and then just point it at an IP address from Azure. That's completely fine as well.
Just before we lose our connection to YouTube, did you guys find Terraform first and then go to AWS, or did you find AWS and then find something to manage?
The second way. So we were already using AWS, so I was already creating things in the console.
Did you try or think about Google and Azure? Or?
No, I tried Azure at one point. Tom and I started up a side project, and Azure gave us free credits to use Azure. So we used Azure and immediately regretted it.
And you wanted your money back?
The Azure console is just incredibly hard to use.
And it changes frequently without warning.
Just lost that friendly.
But yeah, mainly stuck with AWS because that's what we know. So it was easier. I'm sure if I bit my tongue a little bit and actually used Azure for something in production, I'd probably get to the same point where like I kind of hate it, but it's like I know it. I don't love AWS, but I know how it works. So.
Are there alternatives to Terraform as well that you looked at? Like, is it kind of the king of the options, or is it a pretty big thing?
Terraform is kind of, it's still actually in beta, funnily enough, but people use it for, it's like version 0.14 now. It's weird.
still been around for like a very long
It's
time.
been around for a long time, like probably almost 10 years now, maybe not that long.
It's still in beta.
Maybe like 5 or 8
5
years, something like
plus
that.
years.
I don't know. It's been around for a while, but they still got it in beta because they keep every new version they break a bunch of stuff. But
Don't worry about it.
New version.
That's a major version.
they use the 0